Hello everyone, in this video you're going to be learning about transformations of absolute value functions. So let me share my screen and we will begin with our notes. So in the previous video we were working with reflections, shifts, and stretches as it pertains to the form. So now we're going to be looking at the transformations using this that we went over at the top. So let's start from left to right. So first we're going to look at, is there a negative out in the front? And here there's not a negative out in the front, it's just +2. So we are not going to reflect over the x-axis. So let's move on to our second one, this a value. If a is greater than 1, it's a vertical stretch. If a is less than 1, it's a vertical shrink. So here I'm looking at the value out in the front, and this is a 2, which is greater than 1. So this is going to be a vertical stretch because it's greater than 1. And we have to say this is very, very strange, but we do have to say it, it's annoying, by a factor of, and then we just write the number. So vertical stretch by a factor of 2. Okay, now we're going to move on to the one in the middle. So remember it has this minus, which makes it weird, and I had to mark it out because I spelled it wrong. So since this is +3, usually we would think, oh, positive is right. Wrong, positive is actually left now. So we're going to go left 3. And then the very last one is this number on the end. It's our k value. If it's greater than 1, it goes up. If it's less than 1, it goes down. Or sorry, less than 0, not 1. So since this is less than 0, this is exactly what you think. Positive is up, negative is down. So this is going to be down 1. Okay, so we are actually going to look at what this looks like in Desmos, and I'm not going to do this for every single problem, but I do want you to see what these look like for at least one. So let's go to Desmos real quick, okay? And I'm going to start with the regular absolute value of x, and we're going to go first with this vertical stretch by a factor of 2. So I'm going to do 2 absolute value of x, okay? And you can see the function went from here to here. Okay, so it's like it's stretching upwards. This is the vertical stretch. See how it's stretching? Use your arms. You have to stretch by a factor of 2. Okay, so let's look at our left and right now. And we had a +3 in the middle. So we're going to see this function go from here, left 3. So let's see, +3. Okay, you can see that it went from there to there. It was moving to the left 3. And then our very last one that I want to look at is our up and down, and it had a -1 on the end. You can see that it's going down 1. So if you need to check your transformations, just type in the parent function, which is the absolute value of x, and see what each of those is going to do one at a time. Okay, so let's go back to our notes, and we'll move on to problem number 2. So this one, I'm first going to look, is there a negative out in the front? Here there is a negative out in the front. So the first thing is reflect over the x-axis. Okay, now we're going to look at this 1/3. So we're either looking, is it greater than 1 or is it less than 1? Those are our only two options. So 1/3, that is actually a third of 1. So it's certainly less than 1. So since it is less than 1, this is going to be a vertical shrink. So it's going to go from here to here, shrinking down here to here. It's not going up, it's going down this way. So this is going to be a vertical shrink, and then we do have to say this, by a factor of 1/3. Okay, now let's work with the -2 in the middle. Usually with minus you think, oh, that's left. Wrong. Okay, this is the weird one. Negative now means go right. So here we're going to go right 2. And then on the end, this is +4, that's up and down. So since it's positive, we're going to go up 4. Okay, I do want to show you what this shrink looks like and what the reflecting looks like, and then we'll move on to our next problem. So let's just go to Desmos very quickly, and we're going to see what it does if you put a negative out in the front. Okay, and you can see that it went from going upwards to going down. So this is reflecting over the x-axis. You can see it's mirrored over the x-axis right there. Okay, so that's what the negative does. So now let's see what the 1/3 does. Okay, and you're going to see it go from here to here. So it's sort of relaxing a little bit. It's not stretching, it's shrinking. So here we go, 1/3. Okay, and you can see it went from here to here. It shrunk. All right, and the rest of the things, we've already done that in the previous example, so you can go back and look and see what those do transformation-wise. Okay, so let's move on to our next one, and this is actually going to be very similar. So there is a negative in the front. That means reflects over the x-axis. We do have a 1/2, so that's less than 1. So this is going to be a vertical shrink, because it's less than 1, by a factor of 1/2. Negative inside of the absolute value is now going to mean right. So we're going to go right 1. And then our last thing is this +3 on the end, and that is normal. So this is going to go up 3. Okay, and let's do our very last one here. And it seems like it'd be easier, but a lot of times this one confuses people. So let's look first at the very beginning. Is there a negative in the front? No, so we're not going to reflect over the x-axis. Then we want to look at our a value, and the a value is the number that is in front of the absolute value. So here you can see that there is no number in front of the absolute value. So a lot of people like to say, oh, well, that's 0. It is actually not 0, okay? Because if there was a 0 in the front, that'd be 0 times that whole thing, and it would just go completely away. So the number that is in front of this is +1. Since there is a +1 in here, it does not qualify to be a vertical stretch or a vertical shrink because there's no equal to sign here. So since it is neither, we're actually not going to do a vertical stretch or shrink at all, okay, because that's a 1. So now let's move on to inside of the absolute value with x. Plus now means left, so this is left 3. And then the number on the end is up and down, and this is normal, so down 2. Okay, so I made a little note here. The parent function is y equals the absolute value of x. And of course, I spelled weird wrong again. I told you guys I cannot spell weird. It always gets me. So weird is not spelled that way. It is actually spelled W-E-I-R-D. Okay, but left to right is the only weird one. So just keep that in mind. The next video we're going to be looking at with graphs. So please stay tuned for that. Goodbye.